Hi there, I'm Ha, and this is just another video of me solving random code problem. So today we have snake and ladders. So I'm just gonna like skip through the confusing description. Um, so basically, what we are trying to do is we need to return the least number of move, right? The least one required to reach to the square n square. So n is 6, right? It is an n by n board, right? N by n board. So we have to go, so the position go from 1 to n square, right, which is 36, right? So we need to return the minimum number of move to get to the last one, right? The last square, 36, n square. And if that is not possible, just return -1, okay? So, so look like, because we are trying to return the number of move, the minimum number of move here, sound like a shortest distance to me, right? So we can use spread first search to do this. Okay, so basically, the position of the square, right? The position of the square are represented through the number here, right? Starting from the left corner, right? Or like this, right? All the way to n square. So in other words, index 00, right? Gonna represent position 36, right? Index like 1, 2, 3, 0, 3, right? Represent position 33, so on and so forth. So somehow we need to convert the position into the row and column, right? And then at each of the value, they're gonna have the index, right? Sorry, they're gonna have the value. So for example, at the bottom, so all of them represented the value -1, right? And some of them have the positive value. So let me just write down. If it is not -1, which means we have the value that we can jump to, right? So this is 15, and then the other one is 35. So which one is that? Uh, so that is, I believe it's 14, right? 1, 2, 3, 4. 1, 2, 3, 4 on the fourth one, and then the second one. So 35 here. Yeah. So in other words, the ladder here means that, okay, if the value at this index, right, or the value at this position, right, the value at this position is not -1, which means it is a positive value that you can jump to. You can use the ladder to climb to, right? So if it is 15, then you can go from position 2 to position 15. Same for here, you can go directly to 35, right? Because the value is 35 here. So on and so forth, right? So we have to start from position 1, right? And then because in the dice, okay, so that is the position, the ladders, right? The position is like how the snake move, right? And then the ladder is you can jump to a position, and then the dice means 1 to 6, right? It has the value from 1 to 6, which means you can go either 1 step, 2 step, 3 step, 4, 5, or 6 steps, right? So depending on the value of the die, right? So for example, we can go like to 2, right? To 3, right? To 4, right? Um, to 3, to 4, to 5, and then to 6, right? And then to set 7, because the dice can go to up to 6, right? 1, 2, 3, 4, 5, 6, right? So if it is 7, we can jump from 1 to up the way to 7, right? Um, and yeah, and the thing is that if we go to position 2, right, we need to check the value at 2. We need to figure out from the position 2, we need to figure out the row and the column, right? So that we can read the value on the board, right? We need to go from the position here, right, to the board, to the row and the column. So we can check that the value at position 2, that is 15, right? So because it is 15, which means we can jump directly to 15, right? So we can write 15 here, right? 15. Okay. And we can repeat the same thing with the other one, right? So from 15, right, we can go to 16. We can go to, sorry, we can go to 16, right? 17, 18, 19, 20, and then 21, right? 15 plus 6 is 21. Oh yeah, I forgot. And at 17 here, we also have the 13. Right? Yep. So again, at 17 here, right? We have 13, right? So we can jump directly from 17 to 13. That's just how the game works. Or or if so for example, if everything on the board is -1, and we have no choice, right? We just have to like go one by one step by one step, right? Like so for example, like 1 to 7, 7 to 15, 15 to 21, 21 to 28, to 27, so on and so forth. So we can jump to 13 here. Right, and from 13, we can go 14, 15, 16, 17, and then 18, right? And then 19 too, the 6, right? Right, and then at 14, right? We can jump directly to 35, right here, because the value at that position is 35. So from 35, right, we can jump to 36, right? Or 37, so on, but 37 is our bound, so we don't care, right? So in total, it costs us 1, 2, 3, uh, 1, 2, 3, 3, and then four steps, right? Right. So this is one step, it is two step, three step, and four step. So that's why the output is 4 here. Okay, so we're gonna use a breadth search, right, to find the shortest path or like minimum distance, right? We can start out at position 1. We can put it into a queue, right? We can start at position 1, and then we got to keep track of the number of moves, right? We can start out at the 0 move, right? Like that, right? This will be starting pose, right? Starting position. This is the move, number of moves, and we need to keep track, right? And then when we process a position, right, we can run through a loop like from 1 to 6. We can add the position to the dice value, right? So the position plus 1, plus 2, 3, 4, 5, and plus 6, right? To get the new position, right? Like this, and then keep going until we get to the 36. And then we need to make sure that the new position, we need to look at the value at the new position, right? And if it has a value like 15 or 13 or 35, like this, and we need to jump directly to that position, right? So, and then because we can jump back and forth, right? We need to keep track of the visited node, right? We need to have a set to keep track of the visited node to make sure that we're not running into an infinite loop, right? So if the new position is equal to n square, right? N multiplied by n, which is 36 here, 6 square, right? Then we're gonna just return the number of moves, right? Plus 1. And yes, because we can jump back and forth, we can have we have to have a visited set so that we don't run into an infinite loop. And then yeah, we just add the new move, the new position, and the new move, right? Number of move into our queue for further processing. Okay, so that is very straightforward. The question now is how can we turn the position into a row and column so that we can read the value here, right? this is position 2. We know that, but like this is like index something 0, 1, 2, 3, 4, 5. Row is 5 and column is 1, right? So how can we go from that number to like this number, right? It's a little bit tricky because we need to be able to read the value in the board. So let's work on that. So the row, right? Row gonna be equal to the row. So row gonna be equal to the row minus 1, right? Divided by the n, right? So let's say in a normal scenario, right? Let's say we are at the top here, right? 1 to 6, right? So let's say this is index 0, for example. Let's say it is on the top, and then we have 6, right? Divided by 6, and I give it index 1, right? So because it is 0 index, so we need to minus 1, right? Divided by n, which is 6. So 5 divided by 6 is we need to floor that, right? It's 0, right? It's index 0. So if it is 7, 7 minus 1 is 6. 6 divided by 6 is 1, right? So if we are at 7, this means we are at index 1, right? Okay, index 1. So if you notice, it is opposite, right? So we can just do n, right? N minus 1 minus the row, right? So whatever index we found here, right, which is 1, we want it to be opposite, right? Because this is, we are going from bottom up, not top to bottom. So y minus 1 because it is 0 index again, right? So n is 6 minus 1 is 5, right? 5 minus the row, which is 1, is equal to index 4, right? So let me write it out. So this is 6 minus 1 minus the row, right? So row is so this is the, sorry, this is the position actually. Position is 7, right? 7 minus 1 is 6. 6 divided by 6 is 1, right? So we have 4. So 0, 1, 2, 3, 4, right? Row number 4, which is correct, right? So that is how we can get the row, right? Not too bad, right? But what about the column? So the column is a little bit more tricky because we can go from left to right, right? But then we can have to go from right to left, right? So so that we know that when the row is odd, we need to do something different, right? And when the row is even, right? Let's say this is even row, this is odd row. Okay. So if the row so okay, so in a normal case, right, the column is gonna be equal to the let's see, the column gonna equal to the um position, right? Minus 1 mod by n, right? Mod by n, because we only care about the column, right? It doesn't matter if it is top or bottom. So let's say 7 here, positions 7. So 7 minus 1 is so let's say 6. Let's go 6 first. When in the even case, right? So in the even case, 6 minus 1 is 5, right? 5 mod 6 is 5, right? Which is correct. 1, 0, 1, 2, 3, 4, and 5. So we are in the correct column here when the row is even. But when the row is odd, right? 7 minus 1 is 6. 6 minus 6 is 0, right? Right. Would which should be correct if the 7 is over here, right? On the first column, right? But now we need to check, right? If the row is odd, right? If the row mod 2 is equal to 1, which is it is odd, right? And we need to do something else, right? Otherwise, we can just keep the column, right? For the even case. So if it is odd, then we need to do the same thing, right? N minus 1 minus column, right? Y minus 1 because it is 0 index, so n is 6. Minus 1 is 5, and then minus the column. And we calculated earlier, which is 0. So we got 5, right? So 0, 1, 2, 3, 4, 5. So we got the correct Okay. So that is everything we have to talk. We have to talk about. So we can code this up now. So we can have the n equal to border line, right? Because it is an n by n board. The row and the column are the same. We need to have a visited set. So we don't run into an infinite loop, and then we need a queue. Right? I have a custom queue here so that I can do shifting in one amortize. We need to push in the. So we are starting at position one, right? And we need to keep track the number of move. Remember, so our queue is not empty, right? So position, position, right, and then move. We go to queue the top. So we need to iterate through the dice value from 1 to 6. Okay. So we need to create a new position, right? So the new position can be equal to the position plus the dice value, right? From 1 to 6. So we can go by one jump, two jump, all the way to 6 jumps, right? Okay. And then you need to get the current position, right? We have the current position, but we need to read the value at this position, right? We need to get the row and the column. Let's create a helper function for that. For get position, we can pass in a new position, right? So we already calculate the new position here, but the new position might be changed, right? If the value in the board at this row and column, right, have a value, which means we can jump directly to that value. So if the board, right, at the row and the column, right, is not equal to -1, which means it is a positive value that we can jump to, right, the ladder. So we can set the new position equal to the board at the row and column, right, if you remember, right? Um, here, right, this part, right, we are starting at position 1, right? We can try every different dice value, right? And if the value at this position um, is not -1, which means we can jump directly to it, right? 15. Okay. And then we need to check like if the new position is equal to n multiplied by n, which means we have found the numbers, right? The target. So we will return a number of moves plus 1. Right? Why plus 1? Because we haven't added the new position into the queue yet, right? So plus 1. Okay, so and if uh right, so for example, right, if we move this one outside, then it should be just be returning move, right, not move plus 1, but we can just return directly into here to save time, right, to short circuiting, save us like a little bit of time. If visited dot doesn't have the new position, right, which means we can add it into our steps, right, and then the queue the push a new position, and then the move plus 1. And if we don't find anything, we do return -1 at the end. Right. So again, we are starting position. This is our position here, right? We're gonna try to go to the new position, right? Trying every single dice value, right? And if the value at that position is equal to, it's not the -1, right? Which means it is a positive number that we can jump to. Then we need to reset the new position, right? If it's a target, we just return with +1, right? Because the new position hasn't been added to the queue yet, right? If we don't have the position yet, we can add the new position to our set and then push it into the queue for further processing, right? So, but how do we get the position, right? The row and the column from the position. So that is the only thing left to do. We can have position here. Okay. So the row, right, gonna equal to mat dot floor, right, of position -1 divided by n, right? And row gonna equal to n minus 1 minus row, right? Because we are going from bottom up, -1 because we are zero index, okay? And the column will be equal to position -1 mod by n for the even case, right? Only for the even case. But if the row is odd, right, we need to do n minus 1 minus 1 because now we are going from right to left, not from left to right anymore, right? Otherwise, if it's even, we can just keep the column, right? And at the end, we need to return the row and the column, of course. And yeah, this is pretty much it. Let's try that. And it worked. Thank you for watching.